So this is just a quick tutorial to show you how to make an XY scatter plot in Google Sheets. It'll also work in Excel with a couple of modifications and fit a trend line. The reason why we're doing this is to model the activity of a radioactive sample, or an imaginary radioactive sample as we have in this case, in order to determine its half-life. So the first step is to get into Google Sheets. Hopefully you'll be already in Gmail or something like that, or Drive. If you don't know how to get here, essentially when you're in Gmail, you'll just need to click this button here and click Drive, and then you'll be somewhere like this, probably in My Drive. You need to make a new Google Sheet and give it a name that makes sense, something like that. Now, you'll want to enter some data. The data that I'm entering at the moment is from an experiment where we used dice to model the radioactive decay of a sample of radioactive isotopes. In this case, I did a number of trials. So I did around about 14 trials. Now, to do numbers in Excel, you can just do a number of numbers, grab the corner till it turns into a cross, and then extend down to the number of trials you want. And I'm going to say dice left. And so this was 60, 47, 38, 19, 17, 13, 10, 8, 7, 6, 6, and 5. From there, now here I just did one sample or one trial, but if you were doing this, for example, a practical in your physics class, you'd probably want to do a number of samples and then take the average, in which case this might be something like 47.5 or something like that, because you've taken the average of a number of results. Now we want to do percentage left. So here we can learn how to use formulas. So all you have to do is go into the cell, hit equals, and then you can select the previous cell and divide that by 60. Now we've chosen 60 here because we started with 60 dice. So that'll give us a percentage. And if we click on that cell and hit format as percent here, that'll actually convert it to a percentage for us. Now if we drag down again, what that's going to do is show us that this cell, it's time for a break, not yet. It's going to show us that this cell is actually 47.5 divided by 60, which is there's 79.17% of the radioisotopes left at that point, etc., etc. And then time passed. Now, in this particular experiment, or this example that I'm asking my physics students to do, I've asked them to select a period of time that each roll of the dice represents. So one of the options that I gave them was 5 times 10 to the negative 23 seconds. So I'm going to use that. Another one was 3 days, etc., etc. But let's work with these seconds at the moment. So I'm going to go equals. Now we've got, well, actually this should probably be 0 here if I'm going to use a formula like this. So I'll just move these down. So after 0 seconds have passed, I'm going to change the seconds. After 0 seconds have passed, 0 seconds have passed. Makes more sense. After 0 roll, 0 seconds have passed. But after one roll, we've got 1 times, and that's just our star, 5 times 10 to the power of, that power is a little hat on the top of 6. So if you hit shift and hit the number 6, you get that, negative 23 seconds. So we've got 1 lot of 5 times 10 to the negative 23 seconds. That's 0. But if we actually format this differently, we're going to find, in scientific notation, we're going to find that we get a little bit more detail there. So, and again, I can drag that down, and we'll find that after 13 rolls, you may have done 13, you may have done 14, you may have done a few more than that. That 13 represents 13, this yellow box here, times 5 times 10 to the negative 23 seconds. Now it is time to plot. So we've got a percentage left here, and we've got time that's passed here. So what we can actually do is just highlight them. What I did there was I selected that, I held the shift button, and I selected this bottom right, and that selected all these. And then we can make charts. So we can insert chart by clicking here, or we can insert chart by going insert chart. Either way is fine. The chart that we're going to choose in this case, you have to go to chart types first, is an XY scatter graph. And that's pretty much the graph you'll always be using if you're doing any sort of experimentation. So we've got XY scatter, but we've seen that what we actually want on the x-axis is we're always going to want time on our x-axis, or we're going to want our independent variable on our x-axis, which in this case is time. So I'm going to have to swap those two axes around. Okay, you may run into challenges like this. So obviously the way that this graph wants to use it is it wants to use the first column that you've highlighted as the x-axis, and the second column as the y-axis. So what we can do is, instead of just swap these around, I can just copy this and say paste special and just paste the values only. But I can always just say this cell should look the same as this cell and fill down. Again, what I did there was I just hit the equals, and I said make this E1 be the same as C1, and that's all hunky-dory. So let's try that again. I'll click the other make chart this time. There is some way of, again, so we're wanting our XY scatter, we're already there, and insert. So here is a plot that kind of plots our data quite nicely there. I might actually just bring it down and make it a little bit bigger so that we can see it a bit more clearly. And from here, the only thing we have to do in order to identify the half-life of our radioisotope is to add a trend line. So I just select one of the data points, and I do a right click. On a Mac, that's control click, and I select advanced edit, and I can go down and I can say trend line. Now, depending on which experiment you're doing, this is going to be a little bit different. I didn't specify what type of trend line that we were doing here, but in this case, we want to do, this to me looks like an exponential relationship, and indeed we know from the formula of radioactive decay that this is going to be an exponential decay. So you just select exponential and then update. This is obviously an approximation and it's not that good, but from this, we're going to have to format this. It might be because of this. I'm just going to drag this up and see if that changes anything for us. Yep, that changed it for us. Okay, so I just needed to make sure that I was using my, that I dragged the formula from that cell up, because I think the formatting of that 0 was setting the formatting for all this. So here we've got, this tells us how many half-lives or how much time has passed. And so looking here, we could say that this is 50%. So a half-life is from here approximately going to be around about 1 point, if that's 1, that's 1.5, maybe 1.7, 1.6 times 10 to the negative 22 seconds. That's the time that passed. We can then look at the next half-life to go from here to the 25 mark, and you could again work out how much time has passed and take a few estimates and kind of average those estimates, reading off different parts of your trend line. From there, you can go to this list of radioisotopes. This is just in Wikipedia, list of radioactive isotopes by half-life. And for this particular activity that I'm doing with my class, you can find which of the isotopes best fits the amount of time that's passed and identify that and provide a bit of justification. So hopefully that's been nice and clear and helped you identify exactly how to make an XY scatter plot in Google Sheets and fit a trend line.